Welcome to Spring Lib.
Of the question, the maximum bending moment of the cantilever beam at point A will be given by mx. Mmax will be equals to 250 multiplied by 5 plus 22.5 multiplied by 8 multiplied by 8 by 2. Okay, so after solving we get mmax equals to 1970 lb feet, or mmax equals to 23640 lb inch. Okay, so now to determine the maximum tensile stress, we have sigma max equals to mmax divided by I multiplied by C2. Okay, so substituting the values, we get sigma max equals to mmax is 23640 and C2 is 0.617 and I is 3.36. Okay, so from here we get sigma max equals to 4341.03 psi, or sigma max equals to 4.34 ksi. Okay, so this is the answer for the part A of the problem. Okay, now moving to the part B. To calculate the maximum compress, in this part, this is the tensile stress. Okay, so now we will determine the maximum compressive stress and maximum compress. This is our tensile stress. Okay, so we can write it as T. Okay, so the maximum compressive stress, sigma max compressive, will be given by mmax divided by I multiplied by C1. Okay, so substituting the values, we get sigma max compressive equals to mmax is 23640 and C1 is 2.269 divided by I is 3.36. So from here we get sigma max compressive equals to 15964 psi, or sigma max compressive is equals to 15.96 ksi. Okay, so this is the maximum compressive stress in the cantilever beam. Okay, so now moving to the part B of the problem. So first of all, calculating the maximum bending moment of the cantilever beam which will occur at point A. So we can write mmax equals to P multiplied by 5 into 12 plus 22.5 multiplied by 8 multiplied by 8 by 2 multiplied by 12. Okay, so from here we get mmax equals to 60p plus 8640 lb inch. Okay, so now the maximum compressive stress will be sigma maximum compressive. It will be equals to mmax divided by I multiplied by C1. So substituting the values, we get sigma max compressive equals to mx is 60p plus 8640 multiplied by C1 is 2.269 divided by I is 3.36, and this value sigma maximum compressive is equals to 14.5. so I am rubbing it to write down the values here. 14.5 psi, so multiplied by 1000, ks 14.5 ksi, so multiplying by 1000 to get in psi. So from here after solving we get P equals to 214 lb. Okay, so now the maximum tensile stress will be sigma max tensile equals to mmax divided by I multiplied by C2. Okay, so substituting the values, we get sigma max tensile equals to mx is 60p plus 8640 multiplied by 0.617 divided by 3.36. Okay, so substituting value for sigma maximum tensile, we get 4 multiplied by 1000 equals to 60p plus 8640 multiplied by 0.617 divided by 3.36. So from here we get p equals to 219.04 lb. Okay, so for the maximum compressive and tensile limit, the maximum value of concentrated load P is equals to 214 lb. So this is the answer for the part B of the problem. Okay, now moving to the part C. So the maximum bending moment for the cantilever beam about point A, for this condition Mmax will be equals to 250 multiplied by A plus 22.5 multiplied by 8 multiplied by 8 by 2. So this will be equals to Mmax will be equals to 250A plus 720 lb feet. Okay, so the maximum compressive stress here will be sigma max compressive equals to Mmax divided by I multiplied by C1. So sigma maximum compressive will be equals to 14.5 KSI, that is multiplied by 1000 to convert into PSI, and Mmax is equals to 250A plus 720 multiplied by C1 is 2.269 divided by I is 3.36. So from here after solving we get A equals to 4.27 feet. Okay, so now the maximum tensile stress equation, sigma max tensile will be equals to Mmax divided by I multiplied by C2. So substituting the values, sigma max T is 4 KSI, so 4 multiplied by 1000 PSI equals to Mmax is equals to 250A plus 720 divided by 3.36 multiplied by 0.617. Okay, so from here after solving we get A equals to 4.38 feet. So for the maximum compressive and tensile limit, the position of the load from point A